All right, everybody. Hope everybody had a good week. This is week 5. We're going to be kind of focusing on causal theory and the different types of causes you might see, as well as kind of starting into what human error is, what are some of the frameworks we use, and why. All right, so initially, what is a cause and how do we know? How do we know what is a cause? The first thing I want you guys to think about is what does it mean to cause something? So beams dropped from a crane. Why has this happened? And how has this happened? Cranes are supposed to hold beams. What could possibly go wrong there? Reactor vessel head cracks. This is an actual, there was a nuclear incident at a Davis-Besse plant where a vessel head did crack due to poor and delayed maintenance over a certain amount of time. But that's the question. How is that possible? Those vessel heads are designed to withstand enormous temperatures, pressures. I mean, what's going on here? And my favorite one, the Tesla autopilot determines that a puppy is less valuable than a mailbox, which is our future of Skynet. I joke a lot of times about automatic driving or autopilot driving. If hope everybody understands that's joking, and also this Ars Technica story is just hilarious. And also, I want you to consider unintended consequences. So typically, when we think of if you were a cause or if there is a cause, then there had to be an effect. You have to cause something. If you just do something and nothing happens, then you didn't necessarily cause anything. So what do we think about with unintended consequences? This is something you may see in some of your accidents that you're analyzing, where maybe at the time decisions were made that weren't intended to end poorly, but ended up doing that because of some unintended consequences. So, the butterfly effects, the famous chaos theory thing, but also I always think about a banana peel. So you have a banana, you're walking down the street, you throw it on the sidewalk because it's biodegradable or whatever. Somebody comes by walking, steps on the banana peel, slips, hurts themselves. Did you cause that injury? We want to think about yes or no. What is necessary to say you did or didn't? And some of those characteristics. Causal chains. So it's really this is where we get tricky, where it gets tricky when we're analyzing incidents. So it can be all argued that all causes are and have been linked since the beginning of time. So some people ascribe to a theory that all causation essentially has a lineage of, any cause or situation has a previous cause that led to that world state. As many things are interconnected, this isn't unlikely that you're going to see this in some of the, especially when we get into systems causation. Everything is a part of the system, so anything can influence a part of the system. So how far back do we go? And essentially, you almost have to bite the bullet somewhere and just say, okay, we're not considering before this moment. And you kind of have to draw that distinction. And we tend to have some kind of an intuition about what's reasonable and what's not, but it's still something to think about. And if no one's aware, Zeno's paradox is an old philosophical paradox. It was largely settled, I think, with calculus, but it was a philosophical paradox, but also a mathematical one. So Zeno was an ancient Greek philosopher and said, okay, if you're going to travel to a place, let's say you're going to go, I don't know what measurement they would have used back then, but let's say 1 kilometer. Well, first you have to go half of a kilometer, and then you have to go a quarter of a kilometer. Then before that, you have to go an eighth, and it goes and goes and goes. And so Zeno essentially argued that we couldn't get anywhere because we always have to go some distance. Realistically, made no sense. This is a pretty typical philosophers arguing about nonsense, but it was a huge mathematical problem for many hundreds of years. But it kind of goes along with this causal chain argument of, okay, well, how far back do we go, and how do we know, or how can we be assured that we're going back far enough, or how can we be caught if we're not going back far enough? In the next couple slides, we'll go into our kind of types of causes. You're going to see a lot of overlap here. You'll see things where the definitions are like, but isn't this with this? Some of these definitions are pulled from a couple different sources. So this is textbook of accident investigation where this group might call it this way, this group calls it another way, but essentially they mean similar things. So direct cause is generally considered the immediate human action or equipment failure mechanism that triggered an event or condition. So this is not a root or apparent cause. This is just the immediate thing that triggered it. An apparent cause are the most probable cause of an event, adverse condition, or trend that, if corrected, will reduce the potential for recurrence to an acceptable level commensurate with the risk. I want you to pay attention to the difference between apparent cause and root cause here. So the root cause is the fundamental causal factor that, if corrected, will prevent recurrence of an event. So if you notice here under apparent cause, we have will reduce the potential for recurrence to an acceptable level commensurate with the risk. Where root cause is the elimination of any recurrence. Those are kind of the differences. And sometimes what you'll see is based on the severity of certain accidents, some entities or jurisdictions, I guess, whatever you want to refer to them as, might prescribe an apparent cause or a root cause depending on certain situations. If it's a relatively minor event and we need to correct some things, but we're not all that interested in eliminating the entire root cause, then an apparent cause might be called for versus a root cause analysis. And a contributing cause. So an event cause that, or an identified cause that, if corrected, would not by itself have prevented the event. However, its presence directly increased its severity or lengthened time to discovery. So it's kind of one of those contextual factors that impacted the overall situation. But its absence wouldn't necessarily have changed anything, but its presence, we can say, did exacerbate it. Here's some more causes. Here's another set of definitions. A physical cause is the physical, oh, I don't know why that's duplicated, sorry. It's the physical reason why the parts failed. This is the reason, again, I'm not sure. My copy was a lot cleaner than this. Weird. This is the technical explanation of why things broke or failed. This is great, fantastic. So the physical cause is essentially the technical reason why there was an error. Sorry about that. The human cause is the human errors of omission or commission that resulted in the physical roots, so the physical cause. Someone did something wrong or did the wrong thing. Now, those might sound similar, but they're not. You either take an incorrect action or you take a correct action, but something made it the wrong choice. We'll get into that in a few slides when we get to human error. And then you'll hear sometimes about latent cause. So the deficiencies in the management systems or the management approaches that allows the human errors to continue unchecked. These will be flaws in the systems and procedures. A lot of times you will have some characteristic of a cause that is latent or that matches with this. Usually there is some kind of a management or organizational failure. Not always, but there usually is a presence there. Now, the physical human latent cause is kind of a nice clean way sometimes of delineating these that can be easier than the direct apparent root situation. So physical cause, how the incident occurred, this is going to be involving the physics and the objective truths of the accident. This explains how the failure occurred. The chain broke. This because of why? Because the weight was too high or something like that. Human cause. What is the error which led to the physical cause? So this is where someone did something wrong. Why? Oh, they used the improper chain or cabling because they misread the box or the procedure or whatnot. The latent cause. This is management system weakness, training, policies, procedures, specs, regulations, etc. Human decision making is grounded on these, and if flawed, it serves to undermine the entire system, which is an important thing to consider. Your latent causes don't have as much immediate impact as what you'd think, but they tend to persist and almost infect is kind of a strong term, but you know what I mean? Like they can affect a lot of things across your organization in ways that you aren't always able to predict or manage. So I've talked before about a Y tree or a Y chain, or there's a lot of different terms for it, but this is kind of how it would look. So a cylinder does not operate smoothly. Why is it that the cylinder doesn't operate smoothly? You answer that question. The strainer was clogged. Why is the strainer clogged? Because the oil was dirty. Why is the oil dirty? Dirt entered the tank. Well, why did dirt enter the tank? It shouldn't. You would assume that the tank is relatively sealed. Upper plate in the tank had a hole and a gap where dirt entered. This is the physical cause. Why was there a hole in the gap in the tank? There was a repair error during maintenance work. See, there's another repeat. Wonder if something went funny when I opened this up on the Mac. I don't know. I have to look at that. That's our human cause. This was a repair error. Why was there a repair error? No procedure to follow. Now we have a latent cause. So, and a lot of times you'll identify different causes, different causal factors and things. And then we get to the messy situation of how do we identify the root cause, which is the one that if we got rid of it, none of this would have happened. And that's a key way to start thinking about these fact patterns. Like I mentioned, your causal terminology will have a lot of overlap. So contributing versus latent cause, they can be argued are relatively similar. Latent cause more specifically calls out organizational factors where a contributing cause could include organizational factors or other ones, but there's still some similarity. Make sure to adhere to the proper guidelines for your application space. And this is why we went through all of those slides. We want to understand the underlying principles of causation and what we're essentially saying. When you say somebody caused something, it's important to understand those fundamental concepts of what we're talking about and why or why not. If we think back to the banana peel example, what could make it not your fault? What could make it your fault? We would think, oh, intent, you planned on it, kind of a situation, like a Mario Kart instance. But there might be other instances where you're at fault. And it's something to think about. Now, when we're talking about actor and action will be a part of every cause. The actor is a something or someone taking the action. Keep in mind, it can be an object. You might have let's say an automatic safety system that actuates improperly. That's still your actor. And the action is it initiated some world affecting action. When I say world affecting, I'm not meaning like huge or describing its size. It's more of a way of describing situations as the world state changed. So we took an action that adjusted the world state of our circumstances, and both are necessary for any cause you put forward. Ooh, I skipped one. So human error. And if you have any questions on the causal stuff, post them. Speaking of which, I put I'll mention at the end too, but I put a note in the Slack of like what the question I want you guys to answer this week is. But yeah, if you have any extras, post them in there. Let me know, because it can get kind of weird and tricky. So human error. The biggest things that I try to get people to remember with human error is it will always win, and it's undefeated. It's never lost. You have to design for it and expect it. No amount of training or procedures can remove it. There is a potential infinite number of variables that can contribute to human error. And this is one of my favorite analogies. So in nuclear, we focus a lot on equipment and components and, high levels of reliability out of these pieces of equipment. And so, we can predict with some certainty how likely it is that a pump will fail in a certain time frame, for example, given X, Y, Z conditions. What we can't do with equipment is handle what humans do. So let's say your pump one day came to work and decided to be a valve. That changes your risk assessment pretty dramatically, but humans do that all the time. Humans consistently show up at work with maybe best intentions, but their head is not in the right place or whatever, and they do not perform at whatever level that they did, or they don't do things correctly. So how do we manage those kind of things, or how do we identify them before we come? So some basic theories of human error. There are three big ones. One from Jens Rasmussen from back in the 80s, the skill rule knowledge framework. James Reason had the mistakes, violations, captures, motors, and some other ones, which is mainly a build on Norman's slips and mistakes model. These are essentially different angles of solving the same problem. Often you'll see them taken together or interchanged. Because they're not necessarily making different claims, they're just framing them differently. And essentially, if you wonder, so I think James Reason's the most recent here, and we're talking, I think it's his book, Human Error was 98. Why hasn't there been any other human error research, big adjustments to these series in the last 30 years? And it's largely because researching human error from a psychological perspective is extremely difficult. Human errors, like what we've talked about before, are fundamentally unintentional actions. So how do you reliably build an experiment where you can provoke an unintentional action and control and measure what led to its occurrence? And that's an extremely difficult research problem. So that's usually why, the research in human error has been difficult. So Jens Rasmussen's skill rule knowledge framework. This is a gigantic wall of text, but essentially these are going to be some more formal definitions. The biggest thing to realize is as we progress from skill to rule to knowledge, what we're getting at or getting with that progression is we're getting less automatic performance, less practice, and higher risk of error. So your skill-based performance tasks are ones that you do automatically. These are, if you're an experienced driver, a lot of the tasks you do in a car are skill-based. You don't even consider them. They are just automatic things you do given the context. Rule-based performances are when you don't totally have a great experience or training level, but you understand roughly the situation that you're in the context or the system. So you're applying a rule from some past experience that's not with the system, but maybe is with a similar situation and trying to apply it to this. This is where a lot of people live when they're being trained in a new environment or task. Also once they have been trained, but they're new on the job kind of thing, you'll see rule-based behavior a lot as they progress towards skill-based. And knowledge-based performance errors are the highest level and the highest risk. So instead of just applying the rules or performing tasks from an automatic perspective, they actually have to take the step back and fully engage cognitively with the task to try to determine what to do in that given situation. We want to try to keep people out of knowledge-based space as much as humanly possible, was the argument. Was that in that instance, a lot of people are struggling in ways that we can't predict, can't manage, and they have a high likelihood of failure, especially if they don't have the familiarity with the situation. And if they do have familiarity with the situation, they likely are not in knowledge space anyway. Here's an interesting kind of selection for some tasks along decision-making characteristics that we might see. And you can look at this as an example of some errors that might have occurred in your accident. So, we might be in activations is a skill situation. When we're talking about that, we're talking about sensory or cognitive activation. So this is you receive the information. That is a skill based no matter what. Rule is where you're going to be integrating that information. Okay, I know what it means when this gauge is reading 75 pounds or whatever it is. I know roughly what that means with the situation and with this system. So I have to apply that rule to this and try to make a decision. Knowledge base is if you sidestep that and go straight to interpretation, you're trying to figure out what does 75 pounds even mean? What are we talking about here? what's the situation we're in, and trying to extrapolate it or deduce that from there. And then you kind of continue down to evaluation, procedure, selection, execution. But this is an interesting way to kind of look at it with some key terms like interpretation and execution that you will be seeing in some of your accident analysis. So next, we're going to look at Norman slips and mistakes. So instead of having the three subsections of decisions, what Norman said is there are two main issues. We have slips and mistakes. Slips are unintended failures of execution. So you meant to hit a button, but you hit the wrong button. You meant to flip the switch, but you flipped it the wrong way. Those kind of things. They are extremely common issues of cognitive performance that we have constantly. Mistakes are errors of thought where a person's cognitive actions lead to actions or decisions that are contrary to what was intended. So you have the proper intent, you just had a cognitive failure. You maybe misremembered the situation you're in, you perceived incorrectly. This could be an instance, I guess a easy example would be if you were colorblind, you might not perceive certain colors in the intended manner, and that might drive you to some specific kind of an instance. I sometimes think about mistakes alongside some learning disabilities, such as like dyslexia and those things, where there's no poor intention there, but your perception or your processing cognitively failed you in that moment. That's basically what we're talking about with mistakes. And then James Reason came along and kind of tried to distill it further. So he argued that slips and mistakes were not precise enough for operational environments. We're talking aviation, nuclear, medical, whatever. He described, these are just some of the big ones, but if you pick up his book, Human Error, he goes into more depth on some others. But the big ones are capture errors and description errors are some key errors that we'll see made, and they help delineate some specific or corrective actions, or let's say things to understand so we can design them away. So capture errors, correct action. You have automaticity. So this is might be a skill-based action, this is something you just know to do, but you received the incorrect result. This is the meant to push a button, push the wrong button. Then description errors, you did the correct action to the wrong object. So, okay, you need to turn on this pump, you flip a switch instead of pushing the button. And there's some blurring in a lot of these instances too. But lapses is the other one he brought in. So we had slips and mistakes, now we have the lapses. This is just pure forgetfulness, pure just straight memory failure. This is the forgetting a step. So, and as the number of steps increase, the likelihood of lapse will increase as well. Then we also have mode errors, which are the correct plan and execution. You knew you had to hit a button, you hit a button, but it's the wrong context. You thought you were in procedure XYZ, but you're actually in procedure ABC, which means you have to hit the switch. That's a mode error. You're in the wrong mode. He also had an accident causation model we might revisit later. It's kind of interesting, but it's not as commonly deployed, I guess, so it might not be as relevant for you guys. So as we look at sources of human error, we have cognitive, which are just like we discussed, our cognitive failures, memory issues, attentional issues, vigilance. We talked a little bit about vigilance, I believe, but anything that requires long stretches of boredom or monitoring something that doesn't change is just error city. And then decision-making failures and their kind of component parts. Ergonomics. So here's some examples of some plain levers. So this is an old story from the birth of human factors. So there was an instance, the story goes, there was an instance in World War II where well-trained, highly skilled pilots were wrecking their planes as they were trying to land. And after some exploration there, they couldn't figure out, they've trained people, they overtrained them, what's going on. The operators couldn't see these levers. They were down below their seat, the pilots, I should say. So they had to reach down and grab one. And originally, I tried. I couldn't find it. Originally, the two levers were identical. So one dropped your landing gear, one put your flaps down. The issue was they were trying to put down their landing gear because they were landing, but instead they were dropping their wing flaps and it was causing them to crash. So some changes and kind of what we ended up finding to be like a huge aspect of human perception is there started being changes to the levers. So this is an early instance where you just have two separate shapes. Your hand can immediately tell. If you've ever driven a car where you have to, if you ever driven a stick shift and you either went to a different car that was a stick shift or you changed your shifter knob, that feels real weird for a while. Or if you ever put a steering wheel cover on your steering wheel, it's just different. We have a really strong sense memory for some of those things. And then some other iterations here were, okay, well, let's make the switch or lever a landing gear with a wheel, and the flaps are the shape of a wing. Those are ergonomic solutions. We're trying to physically change a device or an object so it better aligns with our mental models and just functional performance. Then there are psychosocial sources. So these are going to be teaming or various kind of social implications of the action, and organizational, which are management level stuff, management systems. And those are kind of the big things that I want you guys to consider this week as you go through your, I put this in the Slack, as you go through yours, I want you to identify the causes. If there's a bunch, you can identify some. Are there any causes you see in your reading that aren't mentioned? Do they describe something in a section of the write-up that you think is a cause, but maybe they didn't, and why? Are there any human errors identified? What type? And do you agree with that? And then make sure you're commenting on everybody else's posts. You guys did, there was some really good discussion last week. I like that. And then this has come up with a couple of people, and I mentioned it last week, a write-up report or presentation. To me, the presentations are better. They force you to kind of distill your information down and make those judgment calls on what you think are the most important factors, or if you prefer a formal write-up paper situation. Let me know. Either way, if I don't hear from anybody, I'll assume presentation's great. And I've got kind of like an example put together, but I need to run it by a couple like reviewers just to make sure I'm not missing anything or whatever. I don't want you guys to be confused or led astray or anything. So hopefully that'll be up by the end of the week for at least the slides. If anybody wants to do a formal write-up, then we'll deal with that then. And whatever you do will get posted in Slack, and then everybody is expected, to read through it. If you want to record your presentation, that's fine. Some people have done that before in other classes I've done. But then everybody can comment and kind of discuss some of those concepts. But the idea is that you're going to kind of sum up your accident. What are the causes, what happened, what's the history, what happened after the fact, and etc. So that's kind of where we're at there. Next week, we'll continue through human error a little bit and kind of keep navigating through there. Remember, we identified, I believe it was October 8th. Does that sound right? Yeah, October 8th for the due date on everything. So in the meantime, even though you don't have a slide deck for an example or any kind of a rubric, just be getting those points together, what you think are the high points to those, to your accidents. And that's it. So hope everybody has a good week. I'm gonna try to post the stuff to the Slack more often, and hopefully this lecture will be done processing tonight. I'm not totally sure. I've been having some weirdness with YouTube. So, all right. Yeah, I will talk to you guys later.